Hello. Today we will be explaining the concept and application of Lotka's Law, presented by Team O&G, which includes Daphne Brune, Christina Shanks, and Robert Payette. The history of Lotka's Law originated from Alfred James Lotka, who was a U.S. mathematician, physical chemist, and statistician, famous for his work in population dynamics and energetics. An American biophysicist best known for his proposal of the predator-prey model, developed simultaneously but independently of Vito Volterra. The Lotka-Volterra model is still the basis of many models used in the analysis of population dynamics and ecology today. More on Lotka's law, it contributed to the field of bibliometrics, which is a set of methods to analyze scientific and technological literature. It also relates to the productivity of scientists. Lotka's law, of course named after Alfred J. Lotka, is one of a variety of special applications of Zipf's law. It describes the frequency of publication by authors in any given field. It states that the number of authors making n contributions is about 1 over n to the power of a of those making one contribution, where a nearly always equals the number 2. More plainly, the number of authors publishing a certain number of articles is a fixed ratio to the number of authors publishing a single article. So, as the number of articles published increases, authors producing that many publications become less frequent. So here we explain Lotka's law with the values applied. This means that the number of authors making 2 publications can be solved as 1 over 2 squared, which is 1/4 of those making 1 publication. Those making 3 publications will be solved in the same manner, 1 over 3 squared, which is 11% of those making 1 publication, etc. It is a power function that predicts the distribution of contributors. In the past, it has been applied many times to artworks, articles, and magazines. And now in the information age that we live in today, it can be applied to the information published and used on the internet. Here's a chart that further describes Lotka's law. In our chart example, we say that 100 authors write 1 article each over a specific period. So in the left column, we have number of articles written, and the right, number of authors writing that number of articles. So using the same formula, we have number of articles written being 10. The formula used would be 100 over 10 squared, which is 1. So we have 1 author writing 10 articles. And the list goes on. And when all of those numbers are totaled together, that will be a total of 293 articles, with 150 writers with an average of 1.9 articles for each writer. Now this is an empirical observation rather than a necessary result. This form of the law is as originally published and is sometimes referred to as the discrete Lotka power function. Here is a graph representation of the chart previously explained. As you can see, the x-axis represents the papers written, while the y-axis represents the percentage of authors. And as the x-axis increases, the y-axis will further decrease. And of course, Lotka's law does not just apply to articles and magazines and so forth, but now it applies to information technology and sources such as Wikipedia, open source software, blogging, as well as YouTube. Here's a graph for Linux contributors, a graph of the Linux software map illustrating Lotka's law. The Linux software map is the standard way that Linux contributors announce a contribution. So you can see that the distribution is essentially identical to the prediction made with Lotka's function. As the x-axis increases, the y-axis decreases. Lotka's law can also be applied to social media and Wikipedia. We use Twitter as our example for social media. This graph depicts the relationship between the number of Twitter followers on the y-axis and the corresponding rank of the Twitter account on the x-axis. Spot the lonely point in the upper left corner of the graph. That point informs us that around 94% of Twitter users contribute to the number one ranked Twitter account. Let's put this to a real-life example. Singer Lady Gaga is ranked number one on Twitter with more than 6.5 million followers. She is closely followed by Britney Spears with around 6 million Twitter followers. This proves to us that Lotka's law can be applied to contemporary online developments. So as the number of Twitter followers increases, the number of Twitter accounts that have that many followers become less frequent and also have a higher rank. As one can see on another graph, the same regularity is found for the number of most visited Wikipedia entries. The most visited entry is one on the actress Brittany Murphy with around 5 million views, followed by the entry on the Avatar movie, which received around 4.5 million views. So the power of law for media can be stated as such. Only a small fraction of the total population of events comprises of cases that receive a huge fraction of reception. Let's look at an example of Stack Overflow. Suppose there are around 25,000 Stack Overflow users who posted answers on exactly one day between March 3rd and March 30th. How many users would be expected to have answered posts on exactly 2 days in March? 3? How about 4? It would make sense for the numbers to be decreasing, but how quickly would they decrease? One standard guess is that the numbers satisfy a power law. More formally, you might look at Zipf's law, which is the number of users who post on n days should be proportional to 1 over n to the s for some value of s. In many examples, s is close to 1. But in Lotka's law, we suggest that s is very close to 2 instead. She would expect that around 6,200 users would post on 2 days, 2,800 users on 3 days, and 1,600 users posting on 4 days. However, the actual numbers are 5,761 users posting on 2 days, 2,709 users posting on 3, and 1,586 users posting on 4 days. So the plot of actual numbers are predictions from Lotka's law, which gives a more precise answer. Websites and blogs also have the same unique distribution of Lotka's law. The distribution of the number of unique visitors for 1,000 most visited websites on the internet is depicted here. All x-axis represents ranks, and all y-axis represent frequencies. In summary, Lotka's law is a special variety of Zipf's law. It is essentially an inverse square power function that originally predicted the distribution of authors to publication. It has since shown to be accurate for contributions in different areas such as articles, magazines, and now, of course, more recently and more prominent is information technology on the internet. For your reference, here are the sources Team ONG utilized for our research. Once again, this has been a presentation on the application of Lotka's law today, presented by Team ONG. Thank you very much.